Hello everyone. So today I'm going to go over trends in covalent radii, the covalent radius, how it changes over the periodic table. So start off basically drawing a couple of diagrams to illustrate this for you. Okay, two atoms. So the difference from probably be able to have done that at the beginning. Okay, so that distance is the bond length, okay? Okay, and if you have okay, slightly, it should be like that, but slightly skew withdrawn. So if you take okay, so improvised ruler, that's half, okay? So that distance is, okay, that, this acrobatics, when your hand's under a camera, you kind of pen things to acrobatics sometimes. Apologies. So that length is this is the covalent radii, okay? So basically half the bond that equals the covalent okay, also called the covalent radii. Okay, so that's simple diagrams to illustrate how it works, the idea of it. So yeah, from one nucleus to the other nucleus is the bond length, and half that distance is the covalent radii. So how does this so going across the period, okay, so that means going across that way from lithium through boron carbon up to neon, okay, all going that way, basically going from left to right, okay. Going across period leads to you get the atomic, sorry, I call it the covalent radii. It decreases, okay? So going across the period, the covalent radii decreases. Okay? This is the main trend. We're going down a group. Okay, so that means going down hydrogen, helium, lithium down to cesium, francium, or moving down carbon, silicon that way. So going from top to bottom. Going down group, the covalent radius, okay, increases. Okay, so the reason why it decreases, the reason for the decrease is because as you move along the group, as you move along the period, sorry, not the group. As you move along, as you go from left to right, the number of protons in the nucleus gets bigger. The nucleus is getting bigger, more protons and more neutrons. Okay, so the reason the atomic radii decreases is because as you're going this way, the number of protons gets bigger, so the positive charge is getting bigger and stronger, more and more positive. So that pulls the electrons in towards the nucleus more. Hence the atom shrinks. As you go down a group, although the number of protons in the nucleus is getting increasing bigger and bigger and bigger, as you go down, every time you go down one level, there's an extra electron shell. So here there's 1 electron shell, here there's 2, here there's 3. When you get down here, there's 7 electron shells. So the atom size is getting bigger and bigger and bigger as you go down. Okay, so the outer electrons are very shielded from the inner nucleus by lots of other layers of electrons. So the atom very quickly gets very big. So that's why going down the group, the covalent radii gets much bigger. Okay. So reason for decrease, as I said, number of protons increases moving from left hand side to right hand side. Okay, so the positive nucleus gets more and more positive, so nucleus gets more and more positive and pulls electron shells inwards. Okay, that's why it decreases. The reason for the increase there's a reason for increase when you're going down, as I said, is because, so to go look, when you're going down from top to bottom, the reason for the increase in covalent radii is because although the nucleus gets bigger, the number of electron shells gets bigger. The number of electron shells gets larger. Okay, so the atoms get very big, okay, and the outer shells are very far from the nucleus. Okay, they're very far from the nucleus. Okay, so that's the influence. The positive nucleus has very little influence in the outer shell electrons because there's a lot of shielding from the inner shell electrons. Okay, so the atoms get very big, the radii get very big. Okay. So yeah, that's covalent radii. I should emphasize, yeah, so this yeah, so covalent radii, yeah, I didn't give a couple, so as you move along I'm just remember realizing that as you move along the periods and the nucleus gets bigger, so the covalent radii shrinks. This sort of applies as you move from lithium to neon, okay? And you move from potassium to argon, and so on. And as you're moving down the groups, okay, and the covalent radii increases, this applies as you move from lithium to francium or carbon to lead, okay? So I just wanted to point that out. That's neon. So as you move from left to right, from lithium to neon, or potassium to argon, the covalent radii gets smaller, and as you move down groups from lithium to francium, as I point out here, from lithium to francium, or carbon say down to lead, or nitrogen to bismuth, I think that is. The covalent radii gets bigger, okay?